All right, so this video will focus on 1.3. And if we look here, the very first thing says find the width of the rectangle. And we have a lot of areas on top and perimeters on the bottom. And we have to kind of think about what you know. So I'm going to give you a moment to do this, but we know that area is length times width, right? And then we know that perimeter equals 2 lengths plus 2 widths. And this is for a rectangle, we're assuming, or a square. But if we look here, so I know that I have one of my things. I have my width, which is 8. So for this one, I'll say, if this is my formula, I know that my area is 32, so I'm just going to plug in what I know. I know 32 equals 8 times W. And we learned before now that I want to get the W by itself, right? So I want to divide by 8 or multiply by 1 over 8. And I'll do it to both sides. I'm actually going to do that instead. I like that. 1/8. And I'll do 1/8 over here. If that's the case, W will equal 4. And that's how I get this 4 right here. So once you know the formula, you can simply plug in what you have and solve for the rest now that we know how to solve equations. So pause for a moment, try to solve these right here. This is 10. This one is 10, and this one here is 10 as well. I just want to show you real quickly number 3. So I'm just going to go over here and go to new. So I know for a fact, again, we said that perimeter equals 2L plus 2W. And I'm just going to plug in what I know. So the perimeter is now 35, so that's the P. I know that my W in this case is 7.5. So I'm going to say 2 times 7.5 plus 2W. I'm then going to rewrite all this. So I'll say 35 equals, this is 15 plus 2W. I'm then going to go through and do the property of subtraction of equality. So 15 on this side, 15 on this side. And now have 20 equals 2W. I'm going to do it by the multiplicative inverse, which is 1 over 2. And this is 1 over 2 as well. So then I have W equals 10, just so we know where this comes from. So how can you solve an equation that has a variable on both sides? That's really what we're doing today. So if we go through here, let's give this a try. I have a few different ones, and I want you to solve for x, and we're going to figure out the area, right? So x times, so it would be like 3 times x, and it's asking to find the, sorry, let's read this again. So solve each equation for x to find its, to find the perimeter and the area. All right, cool. So describe how you check the solution. So in this case here, so in this one, it says that it has the unusual property that the area equals the perimeter. So in this case, I know again that perimeter equals 2L plus 2W, and this is area equals length times width, right? So let's just look at letter A here. And I'm going to have, for area, it'll be 3x, because 3 times x, and that will all equal 2 of the length, which is 2 times 3, and then 2 of the width, which would be 2 times x. I'll rewrite this, and I'll have 3x equals 6 plus 2x. And now I want to get the variable on the same side. So I'm doing kind of what I did before. It's just now I'm going to move the variable over. So I'm going to subtract 2x to both sides. Then I'll have x equals 6. And if I know x equals 6, I now know that 3 times 6 equals 18. So my area equals 18. And let's just see what happens with the other one. If I know that if I plug in 2 times 3 is 6, and then I'm going to write this down here. So I know that let's just see if it works for the perimeter as well. So I know 2 times 3 plus 2 times 6. So 2 times 3 is 6 plus 12, so 18 is the perimeter as well. So that's exactly what it should have been. And we'll do this for all of these. Same kind of steps. Now we're going to say that it says each figure has an unusual property. Same thing, where the area equals the perimeter for each one, and describe how you check your solution. So I'll do this one here, and I know that to figure out the area of this shape, I have to take the area would be 2 times 1, which is right here. And then plus I want to add up this one here, right, which is 3 times x. So that's the areas. And then I have to figure out the perimeter, which would just be the distance around. So these numbers come from this. I have my 2, my 1, that's where these numbers come from. This is x, then 3, then x again. Now I know this whole side equals 2, but this whole side equals 3, which means that this right here equals 1, right? And then this is also 1. So now I'm going to combine all these together, and I will have, in this case, I'll have 2 plus 3x equals, and now I have to add all these, so I'm going to add all the x terms together. So I have 2x, and then add all of the numbers together. So I have 2, 1, 3, 1, and 1. So that'd be 3, 6, 7, 8. So 2x plus 8. I'm then going to go through and start solving this, and I'm going to subtract 2x on this side, because I always like to isolate the variable or move over the coefficient, we'll call it. So I'll say 2x here, and then I'll have 2, bringing this down, plus 1x equals 8. I'm then going to want to move over this 2 over to the other side, so I'll subtract 2, the property of subtraction of equality, so minus 2. And I'll have x equals 6. So in this case, I know that x equals 6. That's what I'm trying to solve for. So you're doing basically the same steps over and over again for all of these. Doing the same thing with this one here, where I'm going to find the surface area for the volume. So again, to figure out the surface area, we have to figure out all the sides here. So it would be like x times 6 plus x times 6 plus x times 6 plus x times 6 for all 4 of these sides. And then these sides over here would be 6 times 6. So I'll have a total of 6 numbers on the side for the volume, or for the surface area. And then for the volume, it would be 6 times 6 times x. And then I solve them. For working with a partner here, the perimeter of the larger triangle is 150 times the perimeter of the smaller triangle. So find the dimensions. Well, I know that this right here, this is 150 more. So I could actually go through, and I could then figure out what 150, let's see here, if I go, what I like to do is I like to do like 10 over 15, because I'm going to go right here, and then it'll be x over 9. And I want to figure out what this equals. Now it's getting smaller, right? So if I look here, my scale factor has got to be, so for this one it says the perimeter of the larger triangle is 150% of the perimeter of the small triangle. It says find the dimensions for each triangle. So I know that this has got to be 150% bigger than this one here, which means that the numbers are actually 150% larger as well, right? So I'm going to set this up like 10/15 times 9. And the way that I got that is I look for my corresponding sides. And I'm actually trying to find the side for the smaller of the two, right? This x, so it's got to be smaller than 9. So my corresponding sides are either going to be 10 over 15 or 15 over 10. And if I multiplied by the number 9 times 15 over 10, it would actually get larger, right? So I'm going to set it up as 10 over 15, because now it will be less than 1, meaning it will get smaller. So if I take 10/15 times 9, so I'm going to take 10 divided by 15 times 9, I get 6. So my answer for x is 6. And if I go through and I try to solve this, I'm going to have 10 plus 6 plus 8, which equals 24. And then the other one, if I know that x now is equal to 6, right? I'm now going to put that in. I'll have 15 plus 9, and then 6 times 2 is 12. So I have 27 plus 9, which is 36. And if I take 36 divided by 24, it should be 1.5 or 150% bigger. And that is in fact the case. So this one here says describe how to solve this. First of all, you have to move over the x terms. Then you want to move over the numbers. So let's just go here and say x plus 5. And that will equal 3x plus 1. So I'm going to go through and I have to first of all make my line going down. And I'm going to first of all move over my variables. So I'm going to say minus x. And I'm moving over the smaller one because I want to try to keep the variables positive if possible. You don't have to. Either way will work, but I try to keep them positive if I can. And I'll have 5 equals 2x plus 1. I now have to move over this 1. So again, the subtraction property of equality. So minus 1, minus 1. And I'll have 2x equals 4. Now I want to get the x by itself, so I'm going to do the multiplicative inverse, which is 1 over 2 and 1 over 2. And I'll have x equals 2. And that is the answer. Now I check it. And I'll put 2 plus 5. And the other one is 3 times 2 plus 1. So let's see what these equal. So for the left side of the equation, 2 plus 5 is 7. And then 3 times 2, which is this right here, I just plugged in the 2, is 6 plus 1 is 7. So they do check out. This one here, it says the value of the solid surface area is equal to the value of the solid volume. So it's the same thing that we did before. We have to figure out the surface area and the volume. So find the value of x with that. In this case, it's 5. And in this case, it is 12. So try that out. So we're basically trying to solve equations that have variables on both sides. And to solve equations with variables on both sides, collect the variable terms on one side and the constant term on the other, which is what I keep on doing when I have all the variables or the coefficients on one side and the numbers, or in this case, the constant terms on the other side. That's what I'm doing. So it says here to try to solve this, again, first move over your x terms. So I'm going to actually move over, in this case, it'd just be easier to say plus 2x. And then I have negative 5x equals 15. I want to do that multiplicative inverse, so it'll be 1 over 5, or negative 1 over 5 to both sides. So 15 times 1 is 15, divided by 5 is 3. So the answer is negative 3 here. Let me look here, and it's the same kind of steps where you go through and you first of all distribute everything out. So that's what I'm doing, distributing. And then I'm going to undo, so I have to subtract the 3x from this side, or add the 3x and add the 3x. So now I'll have 1x plus 10 equals 12. You want to get this 10 over to this side, right? So I have to subtract 10. And now I have x equals 2. This one here, same kind of steps. Want to first of all move over this 2. So I'm going to have negative 5x equals 19. So we'll have a total of 6 of these. Oops, sorry. And there are the answers, so please try to solve and figure those out. This one here, you want to first of all draw the line down. Now this one's tricky because if you look at it, if I add 4x to both sides, I'll have a 0. I have no x. So when I do this, I'll have 3 equals negative 7. And that doesn't make any sense. That's not true. So the equation has no solutions if you have it like this. And hopefully you understand why. Every other one, whenever I plug it in, like you'll have x equals negative 7. This one says 3 equals negative 7. And we, of course, know that is not true. This one here, you would simply distribute out. Again, this would be 12 over 2, so this is 6x plus 4. And then I would subtract the 6x. This is the same thing that happened before. If you have 0 x terms, I'm going to have 4 equals 4. Well, I guess in this case, any number will work. So if I look here, I'm going to subtract 6. I'll have 4 equals 4. That is true. So pretty much anything you plug in is true. It has an infinitely many solutions. And the reason why is because this term over here is exactly equal to this term over here. They mean exactly the same thing. This one here, so I'm going to subtract 2x, and I'll have 0x, and over here I'll have 0. So this is no solution. These are exactly the same. Again, the reason why is because half of 6 is 3, and half of -4 is -2. They're the exact same thing on both sides of the equation, so they'll always have infinitely many solutions. Same with this one. And then this one again, it's not equal. There's no solution for it. So two circles are identical. What is the area of each circle? If these two things are equal to each other. So in this case, I can look at the circles here, and I know that x plus 2 equals 2x, because this would be half of the diameter, which would be 2x. I would subtract the x from both sides. I have x equals 2. Now to figure out the actual area of the circle, I'd have to do like 2 plus 2, which is 4. And then it's, let's just write this down. So it is radius squared times pi, right? And if I know that right now, my radius, or half a circle, is equal to 4, I'd have to square that and then times pi. And then that equals 16 pi. And that's how I get this answer right here. This one here, boat travels X miles per hour upstream. On the return trip, the boat travels 2 miles per hour faster. How does the boat travel upstream? Or how far does it travel upstream? So for this one, I know that you have to look at the diagram here. It goes up river for 3 hours, then it goes down river for 2.5 hours. So I know that it goes upstream X miles per hour, so it would be 3 times that X. I don't know what it is yet, I just know it's 3. And then down river, it goes X plus 2 miles per hour. Well, if you look here, it goes 2.5 hours that rate. So I'm going to have 2 times X plus 2. I'm going to distribute, and I'm going to have 3X equals 2X plus 5. Now I have to do that subtraction property of equality to both sides. I'll have 0.5x equals 5. I then want to do the multiplicative inverse or the division property, and I get 5 divided by 0.5, and that equals 10. Now what that means is that x equals 10. So for upstream, when I go x miles per hour, I'm going 10 miles per hour, right? And it says, how far does the boat travel upstream? Well, 3 times 10 miles per hour. That equals 30 miles altogether.